All right, we're going to take a look at some more complex number stuff. We're going to end with dividing complex numbers. We got a couple of examples on those. They can be very tricky, so make sure that you're with us when we get to that. We're first going to start by reviewing the reducing of radicals, and I'll even show you later after the video how we can use our calculator in order to do this. So when we are simplifying a radical, what we can do is one of several ways of doing this. We can take our number, the radicand, 192, and what we're searching for is numbers that have perfect roots. If we can't spot the numbers that have perfect roots, what we want to do is probably use the factoring tree. 192 has a factor of 6 times 32. The way I found this was I went to y equals 192 divided by x, and there was a list. There's a whole bunch of these things, but that was just the one that happened to pop up on my screen. So I'm going to keep breaking this thing down. 3 is 2 times, or 6 is 2 times 3. 32 is 8 times 4, which is 2 times 4. Now I'm actually going to stop right here instead of breaking down these 4s. Remember, what we're trying to do is get numbers to pair out. And since my 4s are going to pair out just like they are, I'm going to leave that one alone. So one of our common factors that we can pull out of this is a 4. And then the second pair that I notice is the factor 2. So that can also get pulled out. And then the 3 did not pair out with anything, so the 3 is going to be left inside of the radicand, or the radical, excuse me. So what we end up having is the square root of 192. Outside will be the two numbers that did factor out, which is 4 times 2. Inside will be the number that did not, which is 3. So this is going to be 4 times 2, 8. Times the square root of 3. If you were to type this in your calculator, you can get these numbers and see if they are equal to one another. So I can just go to my home screen and take the square root of 192, and it's going to give me the decimal answer 13.86 approximately. And then when I put in 8 square root of 3, I'm going to get the exact same number, which is approximately 13.86. So that's one way you can also use your calculator to check your answers to see if you have a simplified version of the answer. All right, now what we're going to take a look at is the i's with multiple powers. One thing we've got to remember with these i's, don't let this overwhelm you here. The i's, what we have is, like I told you, they act like variables. So as if these were variables, just like they were x's. When we multiply numbers, we add up their exponents. So we would have I to the 17th times I to the 30th times I to the 6th times I to the 19th. This is all fine and good. What we end up doing after we do this is we end up with I to the 72nd power. Now if you remember, the i's are in the cycle like we talked about. I personally like to do it this way. If it's an even number, that means there will not be any i's left. So we have two questions. Is it an odd number? The answer is no, so we will not have an I left. And the next question is 72 divisible by 4? Or is it just an even number? All right, so if the 4 goes into this one time, leaving me with 3, and then this goes in 8 times. So 4 does go in evenly. What that means is this will not have an I, and it will always have a 1 in front. In this case, the 1 is positive. So all of this is simply equal to 1. Remember those two rules. If it's an odd number, there will be an I left, and then it's a -1, If the number is only divisible by 2, it's positive 1 if it's divisible by 4. All right, next thing we're going to talk about, this is a very simple concept, but it's going to lead into one of our more difficult concepts. And what we're asking is write the conjugate for negative 3 minus 6i. So if I'm looking for the conjugate of negative 3 minus 6i, very simply put, this is the complex form a plus bi. All we do differently for the conjugate is leave the a alone and change the b value to the opposite amount. So in this case, the conjugate to negative 3 minus 6i is negative 3 plus 6i. And that would be our answer to the third example. Now we're going to explain why we use this. Again, put that down in your Delta Math. That is the answer, negative 3 plus 6i. Remember, it's the value in front of I that changes. So if the b is in front, you need to move it to the back, and then you can take the conjugate. But here's what the conjugate does. When we take the original number, in this case that was negative 3 minus 6i, and we multiply it times its conjugate, negative 3 plus 6i. So we have conjugates. When we distribute this out, negative 3 times negative 3 is positive 9. Negative 3 times 6i is negative 18i. Here's where the magic comes in. Negative 6 times negative 3 is positive 18i. So you see our i's in the middle are going to cancel. That's what happens when you multiply conjugates. So when we multiply negative 6 times positive 6, this is going to give me negative 36 I squared. As we talked about just now, our 18 I cancels with the negative 18i. So we have 9. And then don't forget this little rule we talked about. I squared. I squared is negative 1. So what ends up happening here is we end up with negative 36 times negative 1, which of course is positive 36. So we end up with 9 plus 36, which is 45. So the number 45, it doesn't mean anything to us on this one. It's just the fact that when you multiply a number times its conjugate, you're going to eliminate your I values. And by the way, that is the difference of square relationship that we see there. Plus and minus the b value. That's how we would get rid of I values. All right, now we're going to talk about how we use this in actual problems. So we cannot have an I in the denominator because an I is a radical and radicals do not belong in the denominator. So I've got to get the I out of this denominator. So the way I do that is I cannot just multiply times negative I, because then the I would just move over to the 2 and it doesn't get anything accomplished. So the only thing I have to do, and I can do here, is to multiply each side by the conjugate of the denominator. So that would be 2 plus I. Since I did it to the denominator, I have to do it to the numerator. So we end up looking like this. Now you take a little side note here. I will work this out, but just so you know, anytime you have this, it's equal to the a term squared minus the b term squared. So 2 squared is 4. I squared is negative 1, of course, so this is going to end up being 5 in the denominator. But we'll FOIL this out because you're probably not as accustomed to using the difference of squares. I'm going to fix a problem that will be an issue in just a moment if I don't put parentheses around that. So I'm going to carry all of this stuff down real fast. So there we have that. When we multiply the denominator, I'm going to start with the denominator anyway, just because if I don't have it right, I don't want to go too much further. 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2I, and again, there's those i's disappearing on us. And negative I times I is negative I squared. Make sure you pay attention to your signs on that. I'm going to go ahead and work this denominator out. Those are like terms that cancel one another. And we've already discussed this. Here's the part that, like I said, this can be tricky. It is negative I squared. Well, I squared is negative, so negative 1, so it's negative 1. So what we end up with is 4 plus 1. And as promised, there's our denominator of 5. Now that's called rationalizing the denominator. We've gotten the I out of there. If that doesn't work, then we just wasted some time, so we might as well see if this is actually going to work before we move to the second part. Since it did, we now move to the second part. We are not multiplying conjugates here, so we will be having some i's left, but that's not a problem. I's are not a problem. I's in the denominator are a problem. So now I go to the negative 7 times 2, which is negative 14i. And then negative 7 times, negative 7i, excuse me, times I is I squared. Negative 7i squared, correction. Now let's take a look at some like terms. We've got i's here. Negative 10 and negative 14 together make negative 24i. Little negative 20 doesn't have a friend yet. Keyword is yet, because we have an I squared. When an I squared touches anything, it changes its sign. So that negative 7 is now a positive 7. And then after we do that, what you can see is we've created another pair of like terms. So we'll just take this down below here. Negative 20 and positive 7 make negative 13. Minus 24i all over 5. So what we've done here is we've simplified. We have not solved anything. We have just written this in a simplest form. Well, the thing about that is we should have the same answers. Certain calculators will calculate the i's for you, but if these two values are the same value, then they should be equal, and we could check that with our calculator. We'll talk about that later. But what we've done is we've simplified these. Again, this is one of the trickier things we do, so we'll do 2 of these examples. Maybe we'll go a little bit quicker on this one, but we'll see how it goes. So again, the problem is the fact that we have an I in our denominator. Can't have radicals in the denominator. Get my colors in here correctly. The way we fix this is with the conjugate, 2 plus 3i. What we do to the denominator, we also do to the numerator. Let you in on a little secret. If you take this expression in numerator and put it directly into your calculator, just like I have it written, it's going to give you a number, and that number is going to be correct. So moving forward, we're going to do this the right way, but moving forward, that actually works. I suggest you give it a look, see if you can get it, because one, there's a lot of chances to make a mistake here. I just put it in my calculator right now, and it ends up being 65 minus 13i. We can do the same thing with the denominator. It is 2 minus 3i. By the way, the I button is second, and then the decimal point. put this into your calculator, and it gives you the number 13. So my calculator trick for this is very nice, but you have to know the process, and that is to multiply times the conjugate. Now, we are going to go ahead and do this the right way, though. So I'm going to, again, start with the denominator. And we'll transpose this down real quick. So there it is written on the bottom. Again, I like to work through the denominator because if I'm going to make a mistake, I want to get it fixed right away. So 2 times 2 is 4. 2 times 3i is positive 6i. And you usually know right about now whether you've done the right thing because those i's are set to cancel and they're about to. And then I end by going negative 3 times positive 3 is negative 9i squared. I'm going to go ahead and change that because we already know what this is going to be, so we'll go right down the line again. We've got i's that are canceling out one another. Anytime an I squared touches anything, it changes it. So our negative 9 is going to change to a positive 9. So what I end up with is 4 plus 9, which is, of course, 13. Like my calculator told me when we started this thing. Now we move to the top. We're going to FOIL this out as well. Distribution of 7 times 2 is 14. 7 times 3i is 21i. This is a poor choice of colors. Let's change that real quick. 21i. And again, remember, i's in the numerator are not a problem. 17 times 2 is going to be 34. And that's negative 34i. And then lastly, we go negative 7 times 3, which is negative 51i squared. And like I said, I'd like to make this change right away. Let's not mess around with this thing. It's plus 51. Anytime an I squared touches anything, it just changes it. So we have 14 plus 51, 65. Saw that earlier. And 21 minus 34i, excuse me, is 13i. Talk about something while we have this here. 65 minus 13i divided by 13. Well, can I cancel out my 13 there? No. Although the 13 does go into both of these numbers, I've got to make sure it goes out of the 65. And now that I'm looking at it, I believe it does. So let's see, 65. I can factor out a 13 actually. So here's what we end up with is 13, excuse me. So since we can factor a 13 from 65, this would give us 5 minus 1i, so I'll just put I over 13. And now actually this 13 does cancel. Did not see that one coming. So this answer is 5 minus I. So always be careful, check for GCFs. Probably would have missed that one if I were in too big of a hurry, so make sure that we do check this. We had a GCF of 13, the 13 comes out evenly.